comentarios ahí para... Ya tenemos el... Bueno, este Meetup ahorita que se dio en conjunto con la ayuda de la comunidad de Go, fue justamente porque, bueno, José nos hizo el favor justamente de que, aparte de que va a dar la keynote del día de mañana del evento que tenemos de Network Factory Live, pues nos dijo que sí para charlar ahorita. Justamente nos va a platicar sobre Phoenix. Entonces, pues bueno, ahorita tuvimos ya, creo que teníamos registrado como 200 gentes ahorita para esto. Para mañana tuvimos también igual, afortunadamente, casa llena. Los boletos se vendieron en pues, prácticamente 2 semanas. Y les digo que les comentaba que tengo ahí lista de espera de 25 gentes que me están pidiendo que entras, pero pues el problema es que ya no hay dónde. Ya de verdad ya no hay dónde acomodar, o sea, por más que los quiera meter abajo de las mesas, esto ya, o sea, no cabe más. Entonces, vamos a tener 2 charlas. Empieza José Valim y luego después vamos a tener una plática de esta Verónica, que nos va a platicar, casi estoy seguro, que va a ser sobre el tema justamente del colector de basura de Go. Una charla que ella recientemente dio, creo que fue en Nueva York, ¿no? Me va a dar la plática. Entonces, pues bueno, ya en tu rumor, digo, va a durar la charla como unos 40 minutos aproximadamente. Y después vamos a tener bastante tiempo para que le puedan preguntar todo lo que quieran a José Valim. Entonces, bueno, José, thank you very much.
So, I am Brazilian and I speak Portuguese, which means I can understand a lot of Spanish, right? And when I was coming, I had to fill the immigration forms and everything is Spanish. And I was kind of okay, right? Figuring everything out, that I could read and kind of understand what was happening. The only issue was that apelido is, in Portuguese, is nickname. I was pretty sure the immigration office didn't want to know my nickname. They wanted to know something else. But then I figured out that they meant last name, and I made it to the country. So, today I don't want to talk about Elixir because who here heard about Elixir? Please raise your hands. That's great. So I'm not going to go over Elixir. You can find, there are talks happening at the Elixir Meetup here. There are a bunch of talks online. I want to talk about Phoenix, which is a web framework that runs on the Elixir programming language. So just to get started, those are the words you're going to hear a lot. So Phoenix is a web framework. It is written with Elixir, which is a programming language. And it runs on top of the Erlang virtual machine, okay? So everyone knows what this means here, right? It's the same as in Brazil. Everyone uses WhatsApp, okay? And WhatsApp, they are written in Erlang. They use the Erlang virtual machine. And they are quite open about, besides getting very, very popular a couple years ago because they were acquired by Facebook by 19 billion or something like that. They were always very open about their engineering, right? And they wrote this blog post. It's quite old at this point. It was in 2012. And they were saying they had 2 million connections on a single node. So what was happening here is that we are with our phones, we are exchanging messages with our friends. They had 2 million connections on a single machine. And when we look at the machine, it's quite a powerful machine, right? It's a machine, at that time especially, because the machine with 24 cores, 96 gigabytes of RAM. But even with all that load, they were using just 40% of CPU and memory. Okay? And and that's because they are using the Erlang virtual machine. And how is this related with Phoenix? That's exactly how Phoenix started. So Chris McCord, the creator of Phoenix, he was working with Ruby and Rails applications, and he had one particular application that required a lot of real-time features, required being connected to different clients and exchange information. And then he heard about the WhatsApp case, and then he thought, wait, wouldn't it be great if I could use this technology right here to solve those problems that I'm trying to solve right now, and really struggling to solve them, okay? And Phoenix started exactly with one feature called Phoenix channels. So So the whole idea of Phoenix channel is to connect the client with the server. So the client has an open communication channel, right, with the server, and you have information coming and going all the time. And in Phoenix case, one very common client is exactly the browser. And when we're talking about browsers, we're using JavaScript. So here's how a Phoenix client would look like. So this is kind of a trope that the first code in the talk is JavaScript code, but we're going to get this one into code. So what we're doing here is that we are creating a socket, so the socket opens the connection from client to server, and then we say connect. And after we connect, we create channels. So I can say, hey, I have the chat lobby channel, and now every time a user joins on this channel, I can execute something. Every time someone sends a message, the server is sending a message, right? Oh, there is a new message that arrived because it's a chat room. So someone typed something, and then you're going to receive here, and you can react to this message, right? And then we can even send message. So for example, if it's a chat application, you want to type something, and when you press enter, you want to send a new message to the server, so the server can send it to everyone else, right? And it's very straightforward, right? And that's how he started building kind of applications that require real time with being constantly connected, the client and the server. And how does this, so this is the JavaScript part, this is the client part. And how does it work on the server? So on the server, the first thing we do is that we define a socket, and that's mapping to the client socket, right? And then we say, okay, so here's my socket. And every time someone is joining on chat lobby here, okay, it's going to be handled by the chat lobby channel. And every time someone is joining a room, for example, it's going to be handled by this channel. And in the sockets also where we do authentication and this kind of other stuff. And the channel looks like this. So the channel is just this. So let me roll back. So in Elixir, our code usually exists inside modules, right? So here we define a module with the channels, and this is using the Phoenix socket functionality. And the channel code is very similar, right? We define another module that uses now the channel functionality, and here's how we write our code. So every time a user joins the chat lobby, so every time a user joins your chat application, what do you want to do? You want to broadcast to everyone else in the application, right, that the user joined. So this is exactly what we do, right? So when the user joins chat lobby, we are going to broadcast to everyone that the user joined, and the user that joined has this username, okay? And then every time the client sends a new message, we want also to broadcast that new message to everyone. And this is how the code works. It's really straightforward once you get to the foundation and play with it, okay? And we can take it really far. And, you know, up to this point, right, we are looking at this and we can think, well, that's cool, right? But it's not really anything special. We've seen similar features. We've seen like client connected to the server applications. We've seen that in a lot of places, okay? So what is really the difference with Phoenix, right? And that's what I want to talk about. This talk is not about the code sample, it's about the concepts behind Phoenix and what makes it different to everything else out there, okay? So in order to do that, let's take an outside view. Okay, so here's our server, right? So we have the client, which was the browser, and we have an open communication channel to the server, right, which is our machine. And the first difference here is that Phoenix channels, we say they are transport agnostic, which means you can connect not only browsers, but really any kind of device. So, for example, maybe you want to connect a browser like Internet Explorer that does not really support WebSockets, and then you need to fall back to things like load pooling, right? So that's supported. Load pooling is another transport. You know, maybe you're building your own native mobile application, and you don't want to go, you know, to use a WebSocket. You have a custom protocol that you can use, then you can just implement this custom protocol, this custom transport, rather, sorry, and use it with Phoenix. And we are even talking also about embedded devices, right? So you can, for example, implement a co-app transport that's going to connect the client to the server, right? And everything was designed this way, that it's agnostic and it can replace it easily. And not only that, right? So here's one very distinct thing about this, is that we know, because we heard the case from WhatsApp where they have like 2 million connections on a single machine, we know that this is going to scale vertically really, really well, which means, well, they had a machine with 24 cores, if they buy now a machine with 48 cores, right, it's going to scale well, and they're going to be able to handle even more connections. But more than that, we also want to be able to scale horizontally, which means as we add more and more machines, we want to still work fine. We want all our code to still work fine. And that's exactly what Phoenix offers also. So let's suppose everything's running on a single machine, you're happy, and then you start to get a lot of more offload, and you say, okay, now I need to put another server in production. So you put another server in production, and Phoenix is going to make it go distributed by default. So let's suppose that this browser suddenly disconnects, right? And then there is another request, and it connects to the other server. Everything is going to work just fine, because if you have all the machines, the Phoenix machines, if they are configured, the distribution layer is configured, the information is going to just flow for the machine. So when the browser sends something here, it's going to be sent to here, and it's going to broadcast to all the other clients, okay? So from this outside view, you can see like some really nice and important differences that we gain really just by leveraging the underlying virtual machine. But when we go to the inside view, things get even more interesting. Okay, so here we have the client, right? So everything to the left is the client, everything happening to the right is the server. And so here you can imagine that the client made a connection. So every time, so when I showed the client code, we saw the socket.connect call. And that what it's going to do is that it's going to open a connection to the server. And when it opens a connection to the server, it's going to create a tiny process. And here's very important. Every time I say process, from now on to the rest of the talk, I don't mean an operating system process, okay? I actually mean a very lightweight, cheap thread of execution, like a Go routine, okay? We just call them processes in Elixir. So, you know, when there is a connection from the client, we create this very tiny process. And we can create a lot of them. In the WhatsApp case, did I say they had 2 million connections? They had at least 2 million processes, okay? So go ahead, you can create a bunch of them. So, cool, so every time there's a connection, there is a process, and that process is the one responsible to make it transport agnostic. And now, every time you call socket.join on the client, right, it's going to create a new channel, and every channel is a separate process. And this is very, very important, because after we model every channel, right, so chat lobby, room 1, room 13, after we model each of those as a different process, we gain 2 very important properties. The first one is that those processes, they are isolated, okay, and that they are concurrent. So as Go routines, right, processes, they are all running at the same time, they are concurrent. But different than Go routines, they are isolated, which means that a crash in one process is not really going to affect the other process. And this is really important because, you know, you're writing an application and then the user is connected to the chat lobby, to room 1, room 2, and room 3. And imagine that something goes wrong in room 3. You don't want your whole system to go down, right? You don't want the whole real-time part of our application to go down and bring the connection down. Especially if you're talking about embedded devices where establishing a connection in the first place can be expensive. So what happens is that, you know, if one thing goes wrong here, it's isolated, right? Everything is going to continue running, the connection is not going to drop, right? The runtime is protected. And this is really, really good. You get it for free, you don't need to do anything really. Okay? And they're all running concurrently, which means that, you know, if you have one channel that's waiting for stuff from the database or from an API, the other channels, they're going to continue running just fine. Or if you're doing some processing, it's not going to block the other channel, right? They're all running concurrently. And if we are going to continue with the inside view, at the end, we are going to have a pub subsystem, okay, which is the team responsible for sharing the information between machines. So as I said, if we start deploying a bunch of Phoenix servers, the information is going to find its way for the system, and that's thanks to the pub subsystem that connects all those different machines. Cool, and then we support very different ways of doing distribution. So one is using just Erlang itself, it has a whole distributed layer, but if you are somewhere like Heroku where you cannot have machines talking directly to each other, you can side stuff to Redis and so on. And that's it, okay? And that's how Phoenix got started. It got started with this idea of channels. And But and in a way, I could kind of end the talk here, but it wouldn't really be fair to what Phoenix has become today. Okay? And the reason for that is because the Phoenix developers, they realize at some point that you don't have to choose, right? So everyone looks at you, oh, you have to choose. No, you don't have to choose. Because web frameworks, or generally web tooling, they kind of say this. You have two options. Or you're going to be productive, and things are going to be slow because you're going to do everything for it to be productive, right? Or you're going to be very fast, but you're going to use those particular tools that don't really integrate with everything else, right? Kind of gives you this choice, or it's one or the other, right? Or you're productive and fast, have a fast application, or you go to this very niche thing and you're not going to get the productivity that you want, but you're going to get the performance results that you want. And Phoenix realized, no, we don't need that. We can give you both. You can be productive and you're going to be really, really fast out of the box. And that's what I want to talk about until the end of the talk, okay? So we're going to talk about performance and productivity. And I'm going to start with performance because it's kind of the easiest one to talk about. And before I show some numbers, I just want to say why it's fast, right? Why Phoenix is really, really fast when it comes to performance. And in order to do that, let's go again to the client-server thing that we were just talking about. So every time there is a HTTP request, right, what you can think is that I have a client, and then it comes to the server, and the server spawns a process, right? Those lightweight thread of computations to handle that request. And then there's another client, and there's another client, there's another client. As we saw, we can create literally hundreds of thousands of those, okay? And as we saw before, those processes, they are, again, isolated and concurrent. And this means that crashes are isolated. So if something goes wrong in a request, the other requests are not going to fail, right? That's great. We expect that, right? In fact, one request to not affect the other ones. But even more interesting, data is isolated. So, and this is super awesome for the web. Because what this means is that the data, so if you have a process and that process reads data from the database or for anything, that data belongs only to that process. Which means that we don't have like a garbage collector that's going to do a global pause and collect the data through the whole system because I have a bunch of shared data, okay? So for example, if you get like your application that you have in production and it's not using Elixir, and then you start doing the performance measurements, and then you say, oh, the average case is really, really good. You would say, oh, it's like 100 milliseconds, 200 milliseconds. But when you go to the 99th percentile, it starts taking 1 second. 2 seconds, 3 seconds. And why is that? Because there are some users, right, that are the unfortunate ones that trigger the garbage collection calls, right? So they trigger the thing and they trigger the limit, and then the garbage collector say, wait, I need to stop everything, and it starts doing garbage collecting, okay? With Elixir, this doesn't matter. The garbage collector is per process, and even more important, if you have like fast web requests, sometimes you don't even need to do garbage collection, right? You do the request, you allocate everything, and say, oops, the request is done. And then say, okay, we just reclaim everything. We don't need to even waste CPU cycles doing garbage collection. So that's awesome. And again, because they're concurrent, this should not be unknown for a Go audience. It's going to load balance on both I/O and CPU just fine. Okay, so it's efficient multi-core. So let's see some results. Okay. So here we have language. We have some different tools and frameworks in Elixir, Go, Scala, Node, and Ruby. And you can get more information from these benchmarks here on this. I'm not going to go into a lot of details, but those are machines 10 cores. Okay, those are the things we want to benchmark. Like, you know, I have a very powerful machine. How things are going to perform. And it's really nice to see that we have like plug and plug coming on the top, with Phoenix and Gene coming right after, right? And then we play also. And then you see like Node and Martini Go and the ones with Ruby coming at the bottom. And what is really nice about this, so we're talking about Phoenix. So what is plug? Plug is a very thin wrapper around the web server. Okay, so this is like plug is as simple as you can go, and then Phoenix web framework. And that's what I want to highlight. So when we look at this table, the only things that are web frameworks really is Phoenix, Scala, and Rails. And by app framework, I mean the things that we're benchmarking here, it's like what the web framework generates, which is doing session, checking for flash, it has all the security mechanisms built in. So it's really nice to see that Phoenix is adding a lot of stuff, everything we expect to be productive and start our application on top of Plug. And Evenflow, right, we got just a 10% hit. Evenflow is still really, really fast. And then it's going on par with Gene, which is more of like a library where kind of assembly things on your own. Okay? So cool, that's about performance. I don't want to go out in details. You can check the benchmarks. It has everything about the machines, what was used to benchmark. You can see the percentiles and so on. What I really want to focus about is productivity. And before we go into examples of productivity, I'd like to break productivity in two things really. There's a short-term productivity, okay? And the short-term productivity is like, it's your first time with Phoenix. How you're going to be productive and get the thing and build the prototype you want to build or build the application you want to build, right? So this is the short term, we're getting started. And a lot of the things that count here is having very good documentation, very good guides, very good tooling, right? So you need to have well-defined workflows, generators, and so on. But there are a lot of tools that they sacrifice and then there's something else, right? Which is the long-term productivity. And there are a lot of tools that sacrifice the long-term productivity in favor of the short-term productivity. And we don't want to do that, right? Because after so long-term productivity is like this, you've built your application and then you're running it in production, right? So now you need to start considering a bunch of other stuff. How easy it is really to maintain that thing, right? Or how well you can introspect the system, because the thing is running in production. How can you understand what is happening there and see how requests are affecting your system, how information is coming, how information is going out, and how you're going to maintain the thing on the long term, okay? So let's go through those topics, right? And let's start with short-term productivity. So a lot of short-term productivity is, as I said, documentation and guides. So in Elixir, we say that documentation is first class. So I can even show an example later, but for example, if you're in the terminal, if you type like H and the name of a module and the name of a function, you're going to bring the documentation, show some examples. We have a lot of documentation published online, so you can explore things fairly easily. And Phoenix is no exception, right? And they also have a bunch of excellent guides. Something that's going to help a lot. So something that's going to help a lot with productivity is if you're used with the MVC pattern. Phoenix is also an MVC framework with a slightly different twist. You can find more about it on the website. Something that's really, really great is that we have something called generators. And you may have found generators in other frameworks, other libraries. But here we like to treat generators as a learning tool. We don't want them to become complex pieces, right? What we want it to do is that you go home and you're like, oh, I'm so excited about Phoenix, right? And then you go home and you say, okay, I want to try this out. So you generate your first application, and then you're like, okay, now I want to create an API. Or I want to create a regular HTML5 application with forms. How do I even start, right? So the generators are going to help you with that. They're going to generate some code so you can explore and see, oh, that's how I load stuff from the database. That's how I get stuff from my forms and put it back in the database, and so on. Okay, and we also have generators for, so we have for HTML, for JSON, also for, if you want to explore the channels part, you can use the channel generator. And usually the code we generate is heavily commented, so you can go through it and understand, oh, that's why they're doing this, okay? And then a bunch of other stuff, right? It's going to help with the short-term productivity. So form builders, which is how to get data from the database into HTML5 forms and back. Right? We have, if you are building in particular HTML5 applications, you need to worry things about JavaScript and CSS, so we have a build tool that helps with that. We have live reloading, which is super cool, which is, if you're working on your application and then you change a style sheet or a JavaScript, we automatically reload that. So you don't need to go and refresh the browser and so on. It really speeds up development, again, short-term productivity. So if something goes wrong, we're going to show nice several pages that's going to help you explore everything. Testing is a first-class citizen. And we also have a growing community that is published. So we have a package manager called Hacks of PM. And we have a very growing community. We just hit 1,000 packages, I think. And there are really a bunch of downloads. I think it's about 4 million or 5 million right now. So it's really growing, and that's going to help you be productive in the short term because you can just use a solution that someone else built, right? Cool, but as I said, right, so again, this is nothing really new, right? We can look at other frameworks and libraries that they do a lot of those things. But, and as I said, the part that we're really going to shine is not the short-term productivity. We're going to be as good as everything else. The part we're going to really shine is the long-term productivity, which we aim to be better than everyone else, right? So, and the secret for long-term productivity, right, is something that we call applications. And we are just leveraging something that exists for 3 decades, okay? Because the early virtual machine is that old, right? It's 3 decades. And they have solved a lot of problems a long time ago, and we just leverage them. So let's understand what is this thing applications and how they can make us productive in the long term. So let's go back to our inside view, the 3rd time, or 4th. So what is happening here is that we have the client on the side, we have the server on the right side, and when the client does a request or establish a channel, right, we know that's going to create a process on the server, and those processes, they're lightweight, they're isolated and recurrent. And if there are other clients, right, we're going to create other processes and other processes. So what we have at the end of the day is that we have kind of a TCP thing that is responsible for accepting all those kind of connections and all those processes that are handling those connections, okay? And then those are some processes running our system. At the same time, I said, for example, we have a pub subsystem that is the thing that sends information between machines. And here's the important thing. All of your Elixir code, it always runs inside the process, right? It's always running inside the process. So the pub sub thing, it's going to be running on another process. That is the one that does all things related to pub sub. And because those things, they are isolated, right? I said that the failure in one does not necessarily affect the other. We started thinking, wait, what is going to happen if the pub sub process, it crashes, right? Something goes wrong, and then it no longer works. How are we going to handle that? Right? We kind of started thinking about failures, how failures are going to affect our system. Because they're isolated, we need to think about it more specifically, right? So what we do is that in Elixir and in Erlang, we have those things called supervisors. And the supervisors, they are the things that are going to have your back, right? If something goes wrong in the post-sub process, the supervisor is going to notice that. And it's going to react on it and create a new pub-sub process to continue the job that the pub-sub system was doing. Okay? And so that's the whole goal of the supervisor. It's looking at what is happening in your system, and when something goes wrong, it's going to react to that. Okay? And this is extremely important because it doesn't matter which programming language you choose, if it's a dynamic language or a static language, things are going to go wrong, right? Your application is going to have bugs, especially if it's anything running the network. Sometimes the network just fails. Sometimes the database just disappears, right? So yeah, you have network partitions. So it's for 2 seconds, but it's a failure. So there is no way we cannot write a software that never fails. So instead of trying to, sometimes we write defensive code, right? Like try catch, never, nothing's going to escape here, right? And so instead of writing this defensive code, we have the supervisors, and the supervisors just guarantee that that our pub-sub process is going to come back, right? In order to give another example why this is important, when your machine is not working, what do? You restart it, right? That's exactly what the supervisor is doing. Because maybe your machine went to a weird state for some reason, okay? And then you restart it, and then it starts working. Because when you restart it, right, it goes back to this initial state that's guaranteed to work. And that's exactly what the supervisor is doing. Something went wrong in the pub-sub. We don't know what went wrong, right? That's why it's called exceptions in many languages. It's supposed to be exceptional, right? It's not supposed to be happening. So if something went wrong, let's start a new one, and it's going to be in that state that is good, it's guaranteed to work. And when we look at this, it starts to look like a tree, right? We have a supervisor that has some children, and then we have this other thing here, which could also be a supervisor that has some children. So this is what we call a supervision tree. And when we have a supervision tree, we pack everything into something that we call an application. Okay? So what is an application really? The applications, they package and run our code. Okay? So all of our source files, right, are going to exist inside an application. And even more important, the applications can be started and stopped as a unit. So go to your programming language that you're working right now, and then go to your application and say, how is this thing started? It's really hard to know, right? Because usually we have the start logic spread in a bunch of different places, and then you install plugins or other packages that has their own initialization logic, and you kind of never really know, right? So here with Elixir applications, that's very well defined how the applications are started and stopped. And it's important to say that when you run your code, you don't have one application. You have many applications running side by side. You can think of them as like components, okay? But we call them applications. So we have all those applications running side by side, and each package their own code. Each can be started and stopped as a unit, right? Applications also provide unified configuration. This is great. If you know how to configure, so if you're working in company A, right, in a project there, using Elixir, and you know how to configure that application, when you go to another company or another project, the way you configure the application is the same because it's a unified pattern throughout the whole language, which is really, really good, right? You don't have people reinventing the wheel and having their own configuration system all the time. And applications, as we saw in the previous slide, right? The applications has a supervision tree, which has all the processes. And because all the code runs inside processes, all of our application state is actually visible. And in order to drive, I could like go on and say bullets. And so in order to drive this point home, I want to show something that called the observer, okay? So here I have a Phoenix application I just created, and I'm going to start the interactive, oops, that's not right. I'm going to make it big soon, don't need to worry about this, okay? So I'm going to start a Phoenix application. It's running now with a terminal, and I'm going to start this thing called the observer. And the observer is this very handy tool that gives all the information that we want about our system. So here's a general system information. So Phoenix by default, it's using 30 megabytes, sometimes even less than that. And we can see exactly where that memory is allocated. We can see for how long it's running. In this particular case, my machine is configured to run 1/4 processes. Right now, it has just 137 processes running. How many CPUs it's using, and everything like that, right? General information about my system. We can also have load charts, but because there's no request coming to an application, we're not going to see anything important here. But we have a bunch of other interesting stuff. So for example, in this process tab, you remember that all the code runs inside processes? Here I can see all the processes running my application. I can see how much memory each of those processes is taking. Those processes, each of those, they have like a mailbox where they serve messages and they work on those messages. So here you can see the size of their messages and so on. So this would be the equivalent if you have a panel that you could run in Go and see all the Go routines happening in your system, right? And not only that, you can pick one here and say, okay, cowboy is the name of the web server. I can just come here, double click it, and it's going to open a panel that's going to give specific information about the process, like what started this process, okay? Is this process linked to anything else, right? Where is the memory of this process being allocated? We can see what is the process state. We can see what is the stack trace for the current process, right? It's like if you went to the Go routine and you could see exactly the moment the Go routine is right now, right? So if you're thinking about long-term productivity and you're thinking about introspection, this is it, right? This is the end game. If you think like, wait, my application is having a memory leak for some reason, the memory is growing. You can come here and then you can order by memory, and then you can find what is the process that's taking a lot of memory, and then you can introspect it and get more information. And not only that, right? So those are the processes, right? I was talking about applications. So with Phoenix, when you start Phoenix, you have all those applications running side by side, okay, in that single node. So we have Phoenix like So the name of our application is simple. SSL is if you want to use SSL stuff, you need it. You have some things from Elixir, okay? And those are all applications, and they all have their supervision tree. So Elixir itself is an application, and here is the supervision tree for Elixir. And then you can go and explore, but I want to explore the supervision tree of the application itself, which I named sample. So here what you can do is that this is quite a big supervision tree. So here is the supervisor, is kind of the parent for our thing, right? And then the supervisor has a couple different children. So one of those is the endpoint, which is the thing that's going to accept the web requests. One of the other children is exactly the repository. The repository is the thing that interfaces with the database. So usually, it doesn't matter the language, when you talk to the database, what do? You have a connection pool, right? You have something that has like 10, 20 open connections to the database. So every time you need to read something, you just get something from the pool and you act on it. And here we can see it very clearly, right? It's not hidden through. So those are all processes. So here I have my repository. My repository has the pool, and those are all connections. Okay, those are all connections to the database. And they're all processes. So every time I want to talk to the database, the pool is going to give me a process so I can communicate with it. All processes. And as I said, once we start seeing all those things as processes, we ask ourselves the question, what is going to happen if one of the processes goes down? Okay? So let's suppose that, so here we can see that we have their order, right? 304, 305, 306. So we can think, wait, so let's suppose that something goes wrong with that particular database connection and it crashes. We can simulate a failure here. I can say, okay, I'm going to keep this process. Okay? So I'm expecting to happen because there is a supervisor. We want the supervisor to notice the failure and start a new connection in place of that one. So let's do that. Okay, we killed it. And now when we go back there, right, we have a new identifier because we killed that one and the supervisor noticed and start another one in this place. We can even be more radical, right? Like, let's say that there is a bug in the pool. Let's kill the pool. And then we expect that whole part of the tree. It's like, who saw Guardians of the Galaxy? Right? Remember, like you cut apart and it grows back? It's the same thing, right? You're going to kill here. And see, it's all back with new PIDs. Right, which is exactly what we want. Our system now can handle failures, right? It's going to, we say that it's going to self-heal, right? Exactly like group. So, yeah, let's finish this. Oops. One second, just need to. Okay, so applications, right? We saw this. And so after this demo, let's summarize applications, right? They provide introspection and monitoring because everything is assigned to processes. Those processes belong to the application, which means we can explore as we just saw, right? We saw it live. We can, because everything is in processes, I can actually know what is the application state. We can actually go for that tool, click on things and know exactly where they are, what is their state, what they are handling right now. So we have a lot of visibility into the system. Okay, this is priceless. It's very easy to break into components. So this is a little bit different, right? So imagine that we are building those applications, okay? And then you're working on this application, it's growing with time. You say, okay, this application is starting to get too big. I want to break this application in two, right? Because everything is very explicit, like the start and stop logic, the supervision tree. If your application is growing big and you want to break it into components, you can, for example, just get part of that tree, right, and move it somewhere else into another application, right? Because we have visibility, is exactly what makes it easy to break a big application into smaller chunks, into components. And it gives us the reasoning when things go wrong. Okay? So to sum up, this is the Phoenix Web Framework, and Phoenix is a web framework that's going to be productive, reliable, and fast. You're going to build reliable applications because we can leverage all of those things, right, that exist for 30 years. And it's going to be fast, we saw the numbers, and you're not going to you're not going to lose productivity. I would even argue that you're going to be more productive, especially in the long term. Okay? And as the big button, so if you go to the website and then there is a very big button here that says you can build APIs, right? So it doesn't matter if you want to build an API backend for, I don't know, like an Ember or Angular application, or if you want to build an actual HTML5 app that is going back and forth to the server, or even something real time with channels, right? Phoenix got your back. And there's actually a book was announced a week ago from, I don't have the link, that's my bad, from Pragmatic Programmers. So there's a book called Programming Phoenix. It's a beta. I'm one of the co-authors, and you can now get a more structured approach to learning Phoenix too. And if you want to learn more about Elixir, oh, and there's also Norberto. You can ask him. They are running frequent Phoenix workshops here in Elixir ones too. And if you want to learn more about Elixir per se, you can go to the website. We have a great getting started guide. We have a learning section with a bunch of Elixir-specific books. And finally, I want to thank my company, Platform Tech, for investing on Elixir and on the community for 3 years at this point. More than 3 years, actually. And that's it. So if you want to join the ecosystem, you can also search for Elixir Radar. It's a newsletter we send almost every week, telling you what exciting is happening in the ecosystem, meetups, and things like that. So thank you very much, and that's the talk about Phoenix.
Preguntas. Si no se sienten seguros de preguntar, pueden preguntar en español.
Y comprendo tudo.
Preguntas.
Tienen a José Valim aquí, no le van a preguntar.
Do you think Elixir is a good language for beginners, for people that knows nothing about programming?
So the question is Elixir a good language for beginners? And that's a, so if I'm going to be completely honest, I don't know the answer, right? But we had an Elixir conference happening in Austin a week ago, and I was really surprised to know that people were actually learning programming with Elixir. That's interesting, right? Because we usually expect, I mean, what we most learn in universities and so on is object-oriented programming, and it's kind of a departure, right? But if you think that someone that has no experience with programming, which one is going to be easier for them to learn? It's a hard question to answer, right? And and there are other initiatives like what is it? Junior Beamsters, which is teaching Elixir to kids. It's happening in Denmark, I think. So I think the best way to know the answer is to actually try and get feedback and see how it goes. It may be that the answer that all programming languages are equally easy and hard to learn. So it's important for us to try and collect results and feedback.
Okay, thanks.
Cool, great question. More?
There.
Hey.
Is the supervisor for the applications an external server, or is part of the framework?
So is the supervisor for that I showed it's part of what? So the supervisors, they ship with Elixir. They are right there, and they're also just processes. So I was saying, like, you know, Elixir has first-class documentation. So here I am. So here I will start just Elixir, not starting a Phoenix thing, right? And then I can run. And I said, oh, we have the H function for help, and I can just do H supervisor, and it's going to bring me all the documentation for the supervisor. And here you can learn, oh, how to create one and everything, examples, right? How to supervise something, what are the upsides and downsides. So everything's here and everything's part of Elixir. We also have like documentation on the website. Actually, I'm going to show because I'm really proud of that. Okay, hold on. Okay, it may not work. So more Okay, so those are our docs, and I think we have one of the most beautiful and readable documentation. So those things are looking weird because it's still loading. But you can go search for supervisor, and yeah, the internet's a little bit slow, but you can just go navigate. Supervisor is going to be here. Yes. And you can find information about everything, what are the functions, and so on. You can really explore it.
It's ugly, man.
Cool, thank you. Yes.
Yeah, I saw one of your tweets like a couple of weeks ago where you said that you were against mocking and subbing. I was wondering if you maybe could clarify because it like generated a lot of confusion.
Yeah, so the question is, so I'm not a fan of mocks, right? The testing technique. And it's a long thing, and I have a blog post ready. I just been very, very lazy to publish it. It's written, I don't know, I'm being lazy, but. So my point about mocks is that, so if you go to the original test unit books that define the name for these things, mocks, they are for discovery. They are for discovery the contracts between your system. And a lot of people use mocks today just as a very easy tool to say, hey, I'm going to mock this function that this, so you have a code, right? That's the code you want to test. And this code that you want to test needs to talk to other things, right? And then people, they just go and they mock this, and they mock that, and they mock that. And as the application grows, the number of things that they are mocking for that particular task is growing, and they're not noticing it because creating a mock just became very, very cheap, right? So what I want people to do is that every time you use a mock, you should define a explicit contract. You should define a place. So that's easy to do in Elixir. I think it's easy to do in Go, possibly with interface and so on. You need to define an interface that is the thing you want to mock or the thing that you want to test. Because if in the future you're adding new mocks, you're going to see that you have like now an interface with 10 things in it. And they're going to say, oh, that doesn't make sense, right? You cannot have an interface that's that big. It means that you have this smell. So, and it's not that mocks, they're necessarily bad. So one of the guidelines that I came up with is that, because one of the ways you can call mocks, that if you create a, for example, let's suppose that you create an empty interface that you use in your tests in Go, right? That thing could be considered a mock or a fake. It's just something that you're passing to isolate the particular thing that you're testing from the rest of your code, right? And that's okay to use that mock. So one of the guidelines that I came up with is that it's fine to use mocks as a noun, which means, oh, I have this mock object or this mock interface that I'm passing around. It's not okay to use mock as a verb, because that usually means that you're changing something that exists, right? And you don't want to do that. You want to have the contracts explicit, and you want to create this thing explicitly. It's kind of a long topic. I'll do my best to publish the blog post as soon as possible, and then go with examples in Elixir, why I think it matters, why I think it doesn't matter, and how you can avoid those common pitfalls. Thank you. More questions? Do I have time for more questions?
Yeah, you have time for 2 hours.
Okay. So 2 very long ones. Yeah.
Okay, so you worked before with Rails, and now you are building another web framework, Infinite.
Yeah.
Is there something that you want to avoid that you consider a mistake that was made in
Oh,
Rails?
that's a very good question. So the question is, so I am still part of the Rails core team member, but now I am working with Phoenix. What are the mistakes that I should not repeat? There is a lot of things to learn and to unlearn, let's say. Right? So one of the things that, for example, I pushed really. So when I came to Phoenix later on. I think it was already 6 months in development when I came. So one of the things that I pushed right away is to get rid of the weird singular and plural rules, right? They're extremely bad. It's very confusing. Everyone got confused at the beginning. So we said, okay, everything is going to be singular, right? You have a user module, you have a user controller, you have a user view. There is no reason to have this weird dance. And maybe you're going to have something plural, like you want your route to be /users, but that's okay because it's the boundary of your system, right? It's how the users are accessing your application. It should not leak how you organize your code internally. So I'm really, really proud to say that there's no singular rules no plural rows in Phoenix. And there's a bunch of other stuff that even if at the beginning I was not thinking like, oh, maybe we should not do that explicitly, but because Elixir is a functional programming language, and as a functional programming language, we don't have objects, which means we cannot couple we cannot couple the data with behavior. It simplifies a lot of things, right? Because a lot of the times, one of the mistakes, for example, that we see in Rails, for example, like how the controllers pass the instance variables to the view, right? And you can only do that because the controller is mixing the itself, which is the controller state, the behavior, your actions, with the state. They are coupled together, and then those things are happening magically. And with Phoenix, it's really, really explicit. So in the book, I said, Programming Phoenix, I can read a link later. The first chapters, the first 2 chapters, is exactly building the intuition that happens from the beginning of the request until the end, and how they're just function calls. There is really no weird state that is passing around. We can, similar to how we're looking at the observer thing, where we could introspect and understand things, it's very easy to do that with Phoenix throughout the whole request lifecycle. So for example, in Rails, I wrote a book called Crafting Rails Applications, right? That is just to shine a light on the internals and make it more accessible to everyone. Here we don't need it, right? Because it's very open, it's very accessible, and it's easy for you to introspect and get more information about it. Cool. And one more?
One
Yeah.
more.
Yeah, and then if I haven't answered a question, you can always come, I'll stay around.
What do you think about the Elm language?
Oh,
a bit much for...
So the question is, what do you think about the Elm language? So there are a bunch of very interesting things that I was talking to, not talking, I was like exchanging tweet messages often with Evan, the creator of Elm. And it's really interesting because in a way, what both Elixir and Elm are trying to do is trying to get all those great ideas in functional programming, and in Elixir in particular case, in the other virtual machine, and trying to make it more and more accessible. So both languages have a very strong focus in usability. So that's really, really nice. So in Elm, it's even better than in Elixir, in my opinion, because they were kind of more, so they were more, let's say, in a way brave, in the sense they say, okay, JavaScript is a mess, we're throwing everything out, and we're starting from the beginning. So for example, when you're building with Elm and you have an error message or a type error, it's just beautiful, right? Tell exactly what happened, what you should do. And we also focus a lot on that with Elixir. So we have a lot of shared goals. And as I said, I was at the Elixir conference, I think we had 2 or 3 talks about Phoenix with Elm. So there's definitely a growing interest in getting those 2 together. And and a lot of the things that you learn with one maps to the other, which is things are immutable, so you cannot mutate things anymore. You need to think about transformations, right? So you now have the signals and the events are happening in your system. So there's a lot of things that you learn from one and map to each other. And I'm really excited to see what's going to happen and what things people will be able to build. Okay. So thank you very much for the attention and the questions, and I'll stay around. Yeah. And